I think I've now started recording. Welcome, everyone. It's good to see you all. And today we're going to talk about nonlinear equations. And today I also want to try something that's a bit different. So I'll try to involve you more and myself less. So let's get started with it. I will start sharing my screen. You guys can see it. And here I have the questions which you were just attempting now. And I also have some answers to them. So here's the catch, or here's the deal. I will try to go over them quickly now. I won't say that, I'll just say the answers. You should grade yourself accordingly, or stop me if you have questions or problems. So the answer for the first exercise is B.
That's 6.
Ah,
On the graph, is that 6?
this is -6, yes.
Okay.
Ah, that sucks. That sucks. Yeah, it happens. Yeah, but I mean, the numbering is in a multiple of -2, so maybe that will help you next time to identify it. But yes, they try to trick you, they try to do bad things. You need to be careful. Second one is C. Third one is B. You should stop me. I lost count. I think this is the fourth.
Can you explain this?
The fourth one. Amazing. Thank you, sir. I thought nobody was going to ask it. So, okay, so we have some values of x and y. Which of the following graphs could represent the relationship between x and y? So let's see what's happening here. So 0 is sent to 0. 1 is sent to 1. 2 is sent to 8, and 3 is sent to 27. So if we talk about nonlinear functions, they are functions which do not change linearly, which means there's no fixed jump between each 2 points. So here the jump is 1, here the jump is 7, and here the jump is, in terms of addition. And here the jump is 19. So it doesn't really seem to be fixed step with each time. There is an important observation which one can make here, but I'll try to leave it until the end. So let's say we want to solve this problem without not making this observation. So it's 1, 1, 2, 8, and 3, 27. I would say that this function is increasing. Okay. And by increasing, we go over the x-axis. We walk in the positive direction, like this. So that's us, everybody. And we see if we're going up or down. In this case, we're going down. Because we go in this positive direction and we're going down. Then this function is decreasing. Here, this one is increasing, okay? I'm happy. This one is also increasing, so that's not too bad. The final one is also increasing. So this was a trick to rule out only one answer. Still need to rule out 3 more answers. I'll try to make this brief. So I'll rewrite the values so that we can see them. 0, 0, 1, 1, 2, 8, and 3, 27. Let's take a look at 0, 0. So can you tell me where 0, 0 is on this graph?
Oh, yeah.
Yeah, and the O. The O is the origin, or the origo. So this is where 0, 0 is. So if the point 0, 0 is on the graph, then it definitely should go through it. So this is the case here. But guess what? It doesn't go through it here. Then this is not an answer. Okay. Then we're down to two choices, and we need to make one of them. So if we compare them, this function seems to be a bit slower with the growth. I don't know if that makes sense, but this seems to go. It seems more steep.
At x is equals to 1, also y is equals to 1.
Yeah.
So I can take that to choose from the two options.
Yeah, exactly. Good suggestion by Eosius, I'm sorry. Is to look at the point 1, 1. So this is 1, that is 1. So it also satisfies 1, 1. But this one, the point 1, 1 is not on the graph. And if you look at the relation between y and x, this is just y is equal to x cubed. This is the observation that I was talking about. If you know the graph of x cubed, you know it looks like this. So that should immediately help you rule out two answers. But then the remark by Eosius is really what you need to conclude. So you look at the point 1, because it's the only thing you have here. You don't have the point 8 because it grows very fast. And you make the choice accordingly. I hope this answers it. More. So this is the sixth question. The answer is B. It's fine. 5. No, I said, is this fine?
Oh.
Fine. It's 6. Yeah, okay. Whatever. I'm sorry. This is A. I mean, this is not too difficult to see, right? You just plug in 0. So you get the y-intercept. So this is a nonlinear function, but the y-intercept is still the constant value in the function. Okay, and maybe I'll do 3 more. I don't know how far you guys went. Did you do the first 10 or maybe more? 16 questions. Okay. You also do 16.
I mean, I did up to 6, and then I jumped all the way to the back to the end, and I started reading just randomly.
Okay.
The ones, those books harder.
Okay, then this is probably not productive. Then how about this? Let's now start doing the more interesting questions, the hard ones. And then we'll see. For the questions themselves that you've just done, I will upload them in the exact same order on Moodle. So you can just submit them, check, and then it's an extra step. I know you need to pay. But I hope this will simplify things. This is not helpful because the answer is already there. But it talks about the product of two positive integers. So we have x and y. Their product is 462. The first integer, maybe I'll let x be the first integer. Maybe I'll just call it x1 and x2. Is this okay? Okay, x1 and x2. So the first integer is 5 greater than twice the second integer. Remember the trick where you read from right to left? So twice the second integer, 5 greater. So take second integer, you times it by 2, and you add 5. So you get 2 equations, 2 variables. You plug in. You get x1 times. I replace x1 with this value. So this will be the exact same thing now. But with the substitution. Don't forget to put it in brackets. And you need to solve this. To do so, you need to do the following. Forget about all of this nonsense. If you distribute this part on the right, you will get 2x2 squared plus 5x2 is equal to 462. And if you have the calculator on the exam, you can use it to find this. But to find this, you need to set it in the form where it is equal to 0. So I'll show you what this means in a moment. So you guys have your calculators, right? Thanks to the one with the version. So this looks scary if you're going to solve it by hand. I will, as I said, I will try to set the other side to be equal to 0. So when I do this, I bring everything to one side. I write 2x2 squared plus 5x2 minus 462 is equal to 0. And maybe a brief interlude is the reason why this is more interesting than the other one. So this is not going to be any math document, I think it's just going to be a story. So these are the roots of the function. What are the roots of the function? They are the x values which make it 0. This is a function in x, if you are wondering what this is. So this is maybe some function in x too. And it is a question that interested mathematicians for so many years, finding roots to equations of second degree, third degree, fourth degree. Mathematicians were very excited about this, and they would fight over who would find the right formulas to find like the quadratic equation or the quintic equation, equations for a degree which is higher than 3. You actually can prove that there are no formulas for any equation which is of the 5th power, any polynomial equation. And so it's funny. So people actually dedicated their time, their whole life maybe, to find roots or solutions to this equation. And then we can just come, we can do like this, you know, and we open the math mode. Maybe I should get a Texas Instruments or a Casio so that we know how to use that.
So we are allowed to use calculator in the exam?
Yeah. Can even
For
have
all
a
part,
graphic.
or there are sections that we are allowed to use?
My understanding is that you're not allowed to use the calculator for all sections of the exam.
Oh, okay.
Because you guys have heard of this also, right?
Yeah, this is.
It's a new change. You have decimals. There's also graphing calculator. It's a big change. But
Bismus, where can I find that? Is that on the PC?
Yeah, find it.
so there's an integrated calculator on digital SAT. You
Okay.
can also have access to it. But what I mean here, oh no, this is not it. Go back. Yeah, so it's mode, and then you write choose this, and you write down the coefficients. So this is an equation of the form ax squared plus bx plus c. Now here c is equal to minus 462, and b is equal to 5, and a is equal to 2. So 2, 5, and minus 462. And I solve. I get minus 16.5 and 14. Then I get minus 16.5.
The answer is 14. 14. What was the answer?
Interesting. So it's 14.
Yeah, okay.
Did I copy the equation incorrectly? Ah. Yeah. Yeah, so the smaller of two integers is 14. That is the answer. So we have 42 questions in the hard section. This is an interesting question. F of x is equal to this, and g of x is it's minus 3, and g of x is equal to minus 3 6 to the x. What does an equation with x in the power look like? Let's plot some stuff. I think this is going to be very interesting. But let's say I choose, yes, okay, 3 or 6. So 3 to the x. Usually we're used to x to the third or x to the second. What we're used to. So for comparison, I'll write both of them and show you how they look like. Are you guys ready? So to get closer to the origin. Yes. So this is how they look like. And this is the graph of x cubed. That was the part in the easy question that we saw. Let's say that's the blue function. And as for the red function, so it's not x to the third, it's 3 to the x. And it seems to be growing very fast. So just add 2 and it's exploding. But still, what does this tell us? How do we find how do we find a minimum or a maximum? And what is this function in any way in the first place? Oh yes, I mean yes, yes it is. So this is the function where you take powers of the same numbers. So the exponent is changing. And
We just put the value of x as well.
and you can actually do that. So when we say there is a minimum value at -3, we mean that x is equal to -3. It's a good idea to try to plug in -3 and see what happens. So this is just terminology. So if I say the minimum value is -3, then I'm talking about the y value. If I say the minimum value is at -3, then what? I'm getting a bit distracted. So let's do like Singh just suggested and plug in -3. So I guess -6 to the power of 3 times 3 to the -3 minus 3. And this is -3. You see the answer. Not clever. -3. So a minimum value is a value at which you cannot really go any lower. So if I give you an example of a function that has a minimum value, it's, for example, the very famous x squared, which has a parabola shape. So this is a very, very bad drawing of x squared, but this is how it looks like. So this function has a minimum at x is equal to 0. F of x squared. This is plotted in red. The reason why it has a minimum at 0 is because all the values of this function are positive. So you're multiplying a number by itself. If it's positive, then multiplying it by itself will give you a positive number. If it's negative, then multiplying it by itself will still give you a positive. So that's why it has a minimum at 0 and 0. Now, if you have decimals, you can also try to take a look at the graph of this function. This function actually doesn't have a minimum for interesting reasons. I wish I could talk about this. It's very cool. So it always gets very close to 0, but it never reaches it. But this is not the topic of this course. What I mean to say is that you are in the exam, you need to solve this problem. You identify that you would like to see how the function looks like at -3. So you take a look at it. So this is not precisely the function. This is a function with the power of with the factor of -6. So maybe I will write that. For the sake of precision, it will be the same thing, but -6 times x. Okay, huge difference. But still, you take a look at it at x is equal to -3, which is right here. Zoom in at -3. And clearly it is not a minimum. So you move on, you say this is not a minimum. For the second one, you do the same thing. You guys like to see it. So this is going to be -3 times 6 to the x. So that doesn't look too bad either. But we need to look at x is equal to -3. So that's the goal. Here it is. And clearly it is not a minimum. There are values which are lower than -3. So we just move on and you say either of them are the answer. If you have decimals, then this is nice.
Can
No.
you just like solve them?
Solve me.
Yeah. By rather than just like maybe sometimes that might be possible.
Okay, I mean, if you want to do it faster, here's the. So this is a function where you take the power of the number in a negative exponent. So if this is not already clear, let me maybe clarify it. So let's see what happens, or let's see at least how we define taking powers to a negative number. So do you know what 2 to the minus 2 is?
You just get inverse number 1 by 2. 1 by 2 to the power 2.
Okay, so the minus is like the inverse, the multiplicative inverse, basically. So if a is a number, and which is not equal to 0, its multiplicative inverse, which is 1 over a, can be written as a to the minus 1. If I raise it to the power of 2, the whole thing, then this is to the minus 2. If I raise it to the power of 7, then this is to the minus 7, so on and so forth. So this is a note on exponents in general. If you discuss the exponential function, the specific one which we have in our case, it's minus 6 times 3 to the x. And you want to plug in x is equal to minus 6. And you want to know if this point is special. There's no other way you can go below this value. So let's see, I mean, minus 6 times 3 to the minus 3 is equal to minus 6 times 3, well, the inverse of 3, so it's 1 over 3 to the power of 3. So it's 1 over 1 to the power of 3 divided by 3 to the power of 3. I won't simplify this, I will leave it as it is. So this is a small number, whatever that means. But can we go smaller? Is a question you can ask yourself. So what happens if I plug in, let's say, a value that's greater? So let's say I plug in a value which is minus 1. Then it will be 1 divided by 3. So I'm multiplying. So I will be multiplying by a greater number, so it will be a greater value. But the thing is, when you do the opposite, when you choose, let's say, to the minus 5, then you are dividing 6 by a number which is bigger. Actually, if you keep dividing 6, so by n, and you make n very large, so let's say 10 millions, then the minus 6 gets a very, 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 very small, that it almost goes to 0. So that's why it behaves like this. So that is a property of the exponential function. It grows exponentially and it decays exponentially. It's very extreme. It's very fast at growing and very fast at decaying. And that's some reasoning behind it. Because if you divide any number by a number that's very, very big, you get a very, very small quantity. This is not clear if you've not listened to this before. This is more like having one pizza for the whole faculty, let's say for the whole uni. So basically, you will get almost no pizza. That's the idea. Like imagine you had cut a pizza into 3,643 pieces. So unless it's a very big pizza, then it's fine. So what I want to say is, the only way you would do this without graphing is if you already know how this function behaves. If you already know how this function is like. But naturally, there's not really any reason to say, hey, this function is has a minimum at this point.
So the only way that it could have a minimum at that point is if it equals 0.
If x is equal to 0.
No. If the solution is, so it asks if which of the following functions has a minimum value at -3, and you chose neither of them. The only way that it could be one of them is if they equal 0. Is if y is 0 at that point.
Let me give you a non-example of this. So this has a minimum at 0, right?
Yeah.
But here's this. If I just add 1. So just like we were talking about linear functions, it's the same thing. I raise it one step up. This is x squared plus 1, and it has a minimum of 1, 1.
Okay.
You see? So that's
So
interesting.
so the only way that you can know if it has a minimum is if you graph it.
Yes, or if you know the graph.
Okay. Yeah.
Or if you know the graph.
So you would have to either memorize the graph or graph it to figure that out.
I mean, I don't say memorize. I mean, I don't memorize the graph of x squared. I just see it so many times that I already know it. Like if you see me so many times, you probably know my name.
Yeah.
So I see this function so many times, so I know. I'm really against memorizing. So I don't believe in that, especially in mathematics. But for this type of question, you need to do lots of questions like this. And you need to encounter different types of functions. And you need to look at this and get stuck and not know what to do as well. This is very important, because then you'll say, okay, I don't know how to do this. How can I make progress with it? Then the answer key is not really. Talks about some analysis. Like I would love to talk about all of this, but it's really just the time constraint that's holding me back. Otherwise, this is very necessary and important. So I tell you how to do it in the exam, but conceptually you should of course know. Should know what you're dealing with, but it is a trade-off I have to make from my side. I hope you guys can understand and forgive me. So here we have a polynomial function. A polynomial function is a function where you have powers. I need to put it a bit higher. So f of x equal to x squared or x cubed, or x cubed plus x squared, so on and so forth. This is what a polynomial function is, roughly. Now, which of the following must be a factor of p is an interesting question. This is a very interesting question. And the answer is not obvious. You need to know something beforehand. B, you already said B. Okay, Iosius has a guess, or maybe an educated guess, says B. I don't expect you to know the answer to this, but you can try, of course. X and P of X. You choose -3. Yeah. I'll write some stuff. I have P of X, okay. And I'll just write some factors. So let's say I write x minus 3 is one of the factors. So it's being multiplied by something, Factor, it means that it's a product of things. So just to make it clear. So it's a product of different things.
Sorry, that was a mistake.
Ah, okay, it's fine. It's fine, but just feel free. So how about this? We would put in the factors and we would use the data from the graph. So you put in -2, and then you get, let's say we look at the first one, you put -2, -3, -5. Okay, what does this tell us? It can be anything. Function can be anything. So because specific reason why it can be anything is because we have other factors. We have other factors which can change the function in any possible way. Okay, but let's look at, let's say, -1, for example. -1 minus 3 is equal to 0. Or even better, let's not look at any factors. So I'll tell you something, and maybe you can take it for granted. Maybe. So you can write your function as a product of, x minus a constant, and then x minus another constant, and so on and so forth. So you can write it like this. Say you have the product of n terms, and 0 is the keyword. So why is this true? It's because if you have, let's say this is the first factor, and this is the second factor, and this is the third factor, and so on and so forth, and say you have n factors, and they are equal to 0, then one of them is 0. Right? So this is really the conceptual idea we approach the course with. We approach the question. What do you mean the course? It's very weird. And so this is good, because if this is the case, then we can write down the factors, and we can look at the values which we can plug in to get 0. So my question to you is, what values can I plug in to get 0 here?
-1 and 2.
-1 and 2. That's great. Okay. Okay, that's very good. -1 and 2. Then, if I have a factor, and if I just plug in -1 in one of these factors, and I get 0, then I make the whole polynomial be equal to 0. So that is really the idea behind it. Is it clear for you? Okay, that's why I'm glad you said no. I'm very happy. So we have a product of many things, and let's say it is equal to 0. Then do you agree with me that one of these factors should be equal to 0? Okay, that's good. Now let's say our function has these factors. Then, if I look at the values which make the whole function be equal to 0, I can just look at the factors, the x values, which make one of the factors 0. So if I make one factor equal to 0, I'll make all of the polynomial be equal to 0. So the values that give us 0 are x is equal to -1 and x is equal to 2. Right? Then can you give me a factor which I plug in, let's say -1 to get 0? in these four.
So factor 2.
So in these choices, in which one would I plug in -1 to get a 0? C or D? Are you sure about C? Yeah, D. That probably already tells us it's going to be the answer, but we're not done yet. So we also need the factor, which makes, for which when we plug in 2, we also get 0. And so this is consistent. If I put in 2 here, I get a 0. And that really is the idea behind it. According to the table, I don't know, blah, blah, blah. You just need to focus on the roots. So fundamentally, as I was talking to you a few minutes earlier, this is what mathematicians like to do. They find functions and they try to find the roots. Like a lot of advancements in mathematics have just been driven by this very simple goal, finding roots to polynomial equation. So this is really all they care about. The other data is just distraction. And because this property is nice, if we just multiply one of the terms by 0, we get all of it be equal to 0, then we can utilize that to our advantage.
Why do we have that the polynomial?
The what?
The polynomial.
We assume that. So we assume that the polynomial is equal to 0, and we assume that the polynomial we can write it as a factor of terms. Like here, for example. And this is not obvious, but it is given to you. It tells you that it must be a factor of b. So a factor of a polynomial is a term in the polynomial. And if you just make one factor be equal to 0, then the whole polynomial is equal to 0. And you can really just exploit that. So that is the key concept I want to leave you with for this problem at least. So I hope that's okay. Maybe I'll choose a random question. This is a good problem. So I can do one of two things. I can show you exactly how it's constructed from scratch, which will take me some time, but it will be probably the only problem, the only remaining problem we do. Or I can kind of hand wave it and then just tell you what to do, and then it's done. I will start writing some stuff down. So this is a model of the number of members in a gym. In the first year, m is equal to 1,800 times 1.02 to the power of t. If t is equal to 0, then I just plug in 0 here, and if I raise this to the power of 0, I get 1. So this is 1,800. More generally, this is an exponential function as well, like the one you saw earlier. And exponential functions are interesting. Now, at the first year, it's 1,800 times 1.02. 1.02 is really just it's a percentage. So you just say 100, 1 plus 2%. So after the first year, they stayed as they are, and they got a 2% increase in people, if that makes sense. And if you go on like this, after 2 years, they also grow in 2%, but it's not. They grow 2% compared to the previous year. Because here we have 1 plus 2% squared, but then I can just write this as 1 plus 2%. So at least that's why it's a growth equation. So each year they're growing by 2%, if that makes sense. Now we would like let's not drift away from the goal of this question. So this is a yearly outcome. So T is in years. Now we would like to find a model for Q quarter years. So the rate of change is it's 2% yearly. Then probably we want to describe this equation in a different method. If you look at the choices, they all have 1,800 as their first year. So if you plug in Q or T is equal to 0, you always get that. The initial start was 1,800, so that's not interesting. But here's what is. So let's take some number Q. Let's say we have. I will try to be consistent with these examples. So, how many quarters do you have in 2 years? 8. Okay. So the number in 2 years should be equal to the number in 8 quarter years, right? So Q is equal to 8 should give us the same amount of growth that we get in 2 years, because it's the same time span. And we can now do some inspection. So which function of these, when I plug in Q is equal to 8, I will get 1,800 times 1 plus 2% squared, because that's 2 years. That is a question for you. Hey, what do you think? Sing it. Okay, if you plug in 8 into B, you get 1,800 times 1.02 to the power of 32. So that's the growth after how many years? You can use this equation. So T is in years, and we are raising 1.02 to the power of 32. Then this is how many years? Take your time.
8 years.
8 years, are you sure? I would say 32 because.
There are 32 quarters or that.
So the rate of, so this is quarters. I plug in Q is equal to 8 in the second one. I get 4 times 8. I get 32 here. And so if I get 32 here, then I read off this equation, then this is the accumulation in 32 years. So that is not the answer. We want the answer to be consistent with this time interval or that time interval. You don't have to take q is equal to 8. You can take q is equal to 4. And if you do that, you will get t is equal to 1. Right? So you would get 1,800 times 1.02. And none of the other choices will give you that. That is the answer. Now notice that the question looks a bit scary, but the answer is quite simple. I'm going at a slow pace because that's the style of the sessions, but if you're able to reason this out swiftly enough, then it shouldn't be an issue. So it grows 1.02 each year, then I should just be able to read off the growth by comparing the growth in quarter years and the growth in years. And since this is a multiple choice exam, we have flexibility to do so. The answer is over there. Okay, I'm sorry. It doesn't matter. B, I don't know. Why is it going to be B? Don't see any reason for it. 95%. Yeah. It's like, okay, there's a so here's how I want to try it. I have 2 points. I want to plug them in and see what happens. F of 7 should be equal to 0 on one side, but on the other side it should be equal to a times 7 squared plus b times 7 plus b. Same thing here. Well, a times minus 3 squared plus b times minus 3 plus c. I'll write this as minus 3b. I'll write this as 9. I'll write this as 49. And we know that this is equal to 0. So these two are equal to each other because they're both equal to 0. I can, yes, I can, and it will also still be equal to 0. And this is what I'm going to do right now. So you bet me one step. 9a and 49a, this and that. So I do this. I do a 49a minus 9a plus 7b and plus 3b because I add the inverse of minus 3b. And then c is on both sides. So I just take it away from both sides and it cancels out. This is all equal to 0. I will factor I don't need to factor the A out, but I get A 49 minus 7. And 7b plus 3b is 10b. 49 minus 7 is 42. 42a plus 10b is equal to 0. That's a good time to stop and ask you how you would like to conclude the problem. Can we solve for A and B? Maybe I would do the following. Right. And then A would be equal to minus 10 over 42 of B.
Like
Yeah?
then plug the one of the equations.
So what exactly do I need to plug in is a good question.
So you get A is equals to minus 10 over 42b, right? So
Mhm.
if we go to the first equation, 0 is equals to A times A times 49 plus B times 7 plus C, right?
Mm-hmm.
But we don't know what C.
Oh,
So here's this. There's a fact. We don't need to know what C is actually. There's a fact which we still have not utilized yet, and it's on the board.
A is greater than.
Good. So A is equal to this, right? This expression. It's here, oh, it's there. And this is greater than 1. Is this okay for everyone?
Which means B is negative.
Okay, good start. And so B should be negative, that's one thing. And can you make another observation? So this is a fraction, right? When does it start becoming greater than 1? I have 10 over 42. So you have 10 and 42.
Yeah.
Probably, if you want this to be bigger than 40, if you want this to be greater than 1, then you want the numerator.
Why is it 42?
49.
So it'd be 40, right?
I don't think so. So it's 9 times 49 times A, 7 times B, and C. So 49 times A, 7 times B, 9 times A, minus 3 times B. So I take away 9 from both sides. I take away 9A from both sides. So 49 minus
It's 40.
it's 40. Yes, you are correct. Then this is even nicer because you have minus 1 over 4. Then probably what should be the value for B?
It should be greater than what is it? Minus 4.
So if I plug in minus 4, I get 1. Now if
Yeah,
I
then it
choose,
should be greater than 1.
so yes, so A should be greater than 1.
Yeah.
If I plug in, let's say B is equal to minus 4, I get 1. But what happens if I plug in a number that's smaller, that's bigger than?
You should, yeah, it should be smaller than.
Because if I plug in, for example, 5, which is greater than -4, I will get a negative number. So I need to find a more negative number to switch the sign and get a positive quantity. So b needs to be less than -4. Okay. So b is less than -4, and a is greater than 1. b is less than -4, and a is greater than 1. Then what should the answer be? A, yeah. That should be the answer. Because a plus b yes. So how do you reason for this? Maybe you can share with us. So this is the correct, but maybe you can help me articulate this.
Because so a has to be greater than 1. So in order for that, so when you multiply -1/4 times -4, you would get 1.
Exactly.
And all the other values are.
Yeah, so these two equations.
-4.
Yeah, we have these two equations, but how do we conclude? So we look at a plus b. A is less than 1, greater than 1, and b is less than 4. Then if I take minus b, so if I multiply this by -1, I'll get that minus b is greater than -4. Why am I switching the sign? One to the side. Because if 10 is greater than 1, then -10 is smaller than -1. If you've not seen this before. Is this okay, Saint? The Eosius?
You say what?
So if 10 is greater than 1, then -10 is less than -1.
Yeah.
So to conclude here, if you multiply by -1, you get that minus b is greater than -4. So it's a negative quantity which is greater than 4. Then if I just add these two, it should be, yeah, so if I add the negative quantity, it would be greater than -4. Then if I add these two, it should be greater than -3. You have a number that's greater than -4 and a number that's greater than 1. Then their sum should be a number that's greater than -3. So that's why that's not the answer, or that, or that. But maybe this is bad reason. Let's maybe look at what the graph tells us. So this is obscure. I don't like it. Okay, they do a completely different problem. But let's focus on what we have. B is less than 4. A is greater than 1. B is less than -4. If we just treat them as equations, then A plus B is equal to -3. That's what I want to say. But they're not equations. So A is a value that is pulling to this direction, and -4 is a value which is in that direction. And so if you add them, if you assume the worst case possible, so you take the smallest number, which is greater than 1. I call it 1 positive because it's 1 and you add a very, very small positive amount. And if you look at -4, so I don't take -4, but I take the number that's very close to -4. So I take -4, but I want it to be less than -4. So it's -4, but I take small shift to the left, a negative shift. Then I get, I'm adding 3. But what do I get for 3? I get something that's, okay, -3. But I get something that's a bit bigger than -3. So that's really what it means. If you assume for the sake of contradiction, okay, that was too mathematical. I won't say this phrase ever again. I'm sorry.
Let me just say that since you know that A is greater than 1 and B is less than -4 for B, we can look at the answers. So the answer is -6.
Yeah, you can also do that because it's not. So these are 2 points. So A and B are 2 points which do not satisfy these 2 equations, right? And they give an answer of -3. Then -3 is not going to be the answer. That's a much better way to phrase it. It's a tough one. You're able to do it. It's very good. Maybe I'll say this one more time. So we know A is greater than 1, B is less than -4. Then A is equal to 1 and B is equal to -4 are 2 points which do not, they're not the answer. So A is not equal to 1 and B is not equal to -4. Then A plus B is not going to be equal to -3. That's much nicer than I can say it. I have problems articulating stuff. And so we know that -3 is not going to be the solution, and we know that the solution is not going to be positive. And so we can conclude from this. So this is a very obvious idea, but it's very hard to articulate. If you articulate it this way, I think it is completely fine. And this is really all I wanted to say for today. I think we went a little bit over time. So I apologize for that. Thank you very much. Maybe I'll end the recording and I'll talk for a little bit. Because I don't want to